Well, hello everyone. In today's video, I'll be talking about stack abstract data type. Um, we already know, and we already have an idea about what is a vector and what is a list. Today we're going to talk about stack, which is basically built using vectors or lists, if you will. You can build a stack using either one of them. We're going to talk about stack, and we're going to see how does it work, what is the principle of how does it work, and how do we use the STL to implement and create stacks and perform some operations on stacks. We're also going to see how do we create our own version of stacks. We're going to see the applications that we can use a stack with. So the stack basically follow a very basic principle, and that principle is last in, first out. What does that mean? It basically means when you have a type of data structure, which is a stack in this case, and you're going to start adding elements into the stack, and those elements are going to be added at the end of that data structure. So the last element is going to be added to the stack will be the first element you can take out of the stack. And by another word, we don't have access in the stack elements in the middle or at the beginning. We only have access to the last element in the stack. So as we add elements to the stack, and we're going to start removing elements from the stack, we can only remove those who are at the end of that stack. And this is basically what we mean by the last element was inserted in will be the first element that you can take out of a stack. When it comes to the applications, there is a lot of applications using stack. One of them, in recursion, which again, it's something we're going to be talking about later. Recursion basically, it's a function that's going to keep calling itself. So you need to think about recursion. For example, if you are at the first run of that function, let's say you have a variable called a, but a need to be updated, and the results of updating a depends on the call of the same function when you call it a second time. So a basically is going to be stored somewhere in the stack, waiting for the result that's going to come from calling the stack the second time. But when you go to the second time, you'll be facing the same scenario. So you will have a stack of variables or the data stored inside that stack, and you basically going to have to wait until you get to the base case of that recursion. And once you get to the base case, the process of taking those elements out of the stack will be happening, and the results of taking every single element out of the stack will be used as an input for the next value in that stack, and so on. Now, of course, again, we're going to get to recursion maybe later, and we're going to go back to this example. But that's basically what a stack is. It's basically a type of data structures where follows a very simple principle: last in, first out. Now, when it comes to the implementation of the stack using the STL, the data structure itself, or the objects you can create, remember, first of all, they're going to be templates. And we basically have mainly 4 functions that we use. We can check if it's empty. We can retrieve the last element you have in that stack using the top function. Pop basically is going to remove that element without returning it. And then if you want to add an element to it, you can just push an element into that stack. So those are the main functions. Of course, there's another function called size that will return how many elements you have in that stack. So before let me just keep going with the PowerPoint, and then I'm going to go show you some examples. This is what the stack header file will look like. You can see here we got the default constructor. We have, let's see here, what else do we have? We have the push function, which basically means you're going to push an element there. We got the top, which is going to return an element. We got the pop, which basically is not going to return anything, but it's just, well, in this case, it's going to actually return. Usually it doesn't return anything. It's just going to remove an element, but let's keep going. Remove the top of the item in the stack. Okay. Oh, this is it. The pop. Okay. And then check if it's empty, and then we have the size, which is basically going to return the number of elements. And then after that, we have the private section of this data structure. Again, this is just to show you how a header file will look like. To demonstrate the implementation of stacks, we can have, this is just an example of stacks of type of strings. So you start with the keyboard stack, of course. You need to include the header file stack if you want to use it. You have to specify the data type and you call it names, and then you start pushing names. Now look here, Richard, Debbie, Robin, Dustin, and Jonathan. So you push Rich at the beginning, so it's going to be at the first element in that. And as you push more elements, you can see here that the last element you insert in the stack will be here at the top. Now if you start, let's say, popping elements, or top remember will return the last element. So basically in this case, when I implement this method and call this method, basically it's going to return Jonathan without removing it. But when you say pop, it's going to take it out of that stack, of course. And then after that, you can add more elements if you want. Here it is. We're pushing Phillips there. Okay, now before I jump into the applications of stack, let me just show you the an example of the implementation of the stack. Now remember, those header file, don't worry about them. Let me take them away for now. We're just going to worry and deal with stack right now. So you have to include the header file stack. You can see here I created 2 stacks, for example. This is just for demonstration purpose. I got my stack 2, and I start pushing elements into my stack here. So I push 7, 8, 1, 4, 5, and 9. And then after that, I check the size of the stack and I check it's empty. Of course, it's not going to be empty in this case. And in this case, in this example, in this portion of this project, what I'm trying to do, I am trying to show the elements that I have in that stack. So what I did here, I created a variable called size just to store the size of that stack, and then I had a for loop that's going to go through those elements. Now look what I'm doing here. This is very important. I am reading the top of my stack and I'm pushing it into my stack 2. Okay? And then after that, I am showing my stack. What is the last element that I have in my stack? In this case, for example, the last element is going to be shown as 9 here. And then after that, I'm removing it from my stack. So basically, this one is going to be removed. So when I go back here again, the top now is going to equal 5. So I'm going to take 5 and I'm going to insert it in my stack 2. And then I'm going to show 5 and then I'm going to remove 5. And I'm going to keep going until I get to my first element, which is 7. By the end of this for loop, what's going to happen? Basically, my stack is going to be empty because there will be no elements left because I popped them all. And my stack 2 will hold all the values that I have here in a reverse order. So basically 9 is going to be the first element and 7 will be the last element. Okay, now we use double stacks a lot whenever we want to try to perform a lot of applications. So this is something you have to put in your mind when you use double stacks. Anyway, if I just give this a try, hopefully it will not. I think I'm going to get an error. Yep, I'm going to get an error. Let me fix that real quick because I do have other header files here. Sorry, other main functions here. I just need to change their names. So I'll just go ahead and put 2 here. Then we'll run it again. And here we go. So this is me printing those values. And this 0 is basically because it's empty, so it's going to be true. And this is me printing those values. This is, let me go back to the code and see if this is the size. I got 6 element, and this is the top, the last element that I have, which is 9. And here we go. So this is basically how stack works. Now that I'm done with that, let's go back to the PowerPoint. Now, applications of stacks. There are many, many applications. And I'm going to go through those applications just to explain the concept. And then after that, I'm going to go to the implementation that I came up with. And we're going to have a discussion about that. But those applications, I'm not going to write the code for them. I'm not going to show you the code for them. But it's something that you should be able to get it done by yourself with no problems. So the first one is to find out if a string is palindromes. Now, palindrome strings basically means if you read it from left to right or right to left, you will get the same sequence of characters. Now, kayak, for example, is a palindrome string. Zero Res, that's a company that cleans carpets. That's palindrome. Now, the question is, how do I use stacks to do that? Well, the idea here is very simple. If you have a string, extract the characters one by one and push them in a stack. And then after that, pop those characters from the stack and reconstruct a new string. If the new string you created from that stack is exactly the same as the string that you started with, then you have a case. Okay? Now that's, again, if we're talking about one word, but what if we talk about multiple words with spaces? And what if we're talking about upper cases, lower cases? So will add a level of complexity here. And if that's the case, let's say we have a string that contains multiple words. And we don't want to take spaces under consideration, for example, when we're going to check for palindromes. I don't know if this is a case. No, this is actually a case. It's a good case here. This also is a good case. Yeah, all of them are good. So I think we don't have to worry about that for those examples. But the idea here is we have uppercases here. So this is A and this is uppercase E. Now, of course, if I'm going to apply the concept here and start pushing the letters one by one, for example, A, B, L, E, I'm going to push those elements, those characters into a stack, and then I'm going to actually build a new stack using those elements. You would notice that the element that we're going to get here, for example, the first A that's going to be popped is going to be a lowercase a, because lowercase a was the first element last element we inserted. So if you have a case like this, you have to put under consideration that you need to fix this. How do I fix that? Well, basically, you probably would need to convert this to all lower cases at the beginning, and then you start pushing it to a stack. Same thing here with this level. And the idea, again, is very simple, very straightforward. All you have to do is have a loop, and this loop basically is going to go through those characters one by one. And then assuming you converted the whole string to a lower cases, and then scan that string and push them into a stack. And then the stack you're going to create, once you're done pushing all the elements, start having another loop to pop those characters and build a new string. And then after that, you're just going to have to compare those two strings together. If they are identical, that basically means you have a case of palindromes. This here just to show you a case was okay. This here is just to show you the code that you can, oh, this is Java. I don't know why Java's here. Yep, that doesn't make any sense. Why do I have Java here? Again, it's supposed to be C++ anyway. So this is just to show some information, like if you want to create a project, what do you have to worry about? Those are the attributes and the data fields in that project. Again, this is just a guide if you actually want to write a code for it. And again, it should not be a problem, and you should be able to get it done by yourself, even without the need to have a look at this code. This is, again, just to show you that your project should be able to multiple characters in one word. Okay, that's what we're looking for, a single character. What are you going to do for this case? It's, again, simple. Just going to push it and pop it, and then you're done. Multiple words with the spaces, different cases, upper cases, lower cases, even length, odd length. Well, I don't know how is that going to change anything. If you have an empty string, usually it's considered as palindrome. So you just need to have an if statement for that. So again, this is the first application. And this application, again, it's all about figuring out if a string is palindromes or not, which is, again, something very simple and very straightforward. If I want to write a code for it, it's not going to take that long of time. The second application is to check the balance of parentheses. Now, what I'm going to be doing, I'm going to use the Paint software to show you those applications. This will make it a little bit easier. Oops, what's going on here? No, I didn't ask for that. Okay, so let me just show you. If imagine that we have this string here, and I want to check if this palindrome or not. Well, You're just going to have to create a stack. You need to have a for loop to scan these characters one by one. You get the Z, you push it here. You get the E, you push it here. You get the R, you push it here. You get the O, you push it here. You get another R, you push it here, and then you push E here. And then finally you push the Z here. Now I'm done. Let's call this one string 1. Now string 2, you're going to start popping those elements one by one, and you use the characters you're getting to construct this part. So you can, if you treat each one of those strings as a string by itself, the process is going to be easy. So you're going to get Z here, and then E, and then Z, we're finished, E, we're finished, and then R, and then O, and then another R, and then another E, and another Z. Now all you have to do and check if S1 double equal S2. If that's the case, then yes, you got a palindrome. Okay, so that's the first application. Now we're going to be moving on to the second application, and the second application is extremely important. In expressions, you use usually parentheses, and those parentheses could take many forms. You can have those type of parentheses, you can have square brackets, and you can have a curly brackets. Now, whenever you have an expression, it's very, very important to understand that this expression should be balanced. And a balanced expression basically means for every single opening of any of those type of parentheses, there must be a closing one for it. And we can use stacks to test that. And the way to do that is very simple. I'm going to just give you one balanced expression. And let's say, for example, 3 plus 5, let's say, the minus or multiplied by 6 minus, open parentheses, 5 plus 11, open a curly brace, and then I'll open another curly brace, another square bracket, for example, and I'll put 6 minus 1 multiplied by 3, and then I'll close this one, and then I'll close this one as well. So I got, this is my expression here. So here's the expression that we're supposed to figure out if it's balanced or not. So here's how it works. All you need to do here is to create a stack, and you're going to start scanning your expression left to right. Now, as you scan the expression, every time you find any open parentheses, you're just going to have to push it into the stack. So I'm going to see that I got this square bracket, so it's an open parenthesis, so I'm going to push it. Now after that, I'm going to go and keep going, so ignore this, ignore this, ignore this, ignore this, ignore this, ignore this. Oh, we got another open parenthesis, so we're going to have to put it here. And then you ignore this, and ignore this, and ignore this. And now we have a closed parenthesis. The moment you find yourself facing a closed parenthesis, it doesn't matter which type, you're just going to have to put it on the side, and then you're going to have to top this one and pop it. So top it basically means you're going to store it somewhere, and then you're going to pop it, which basically means remove it. So once you're done with that operation, after that, you're going to have to compare those two parentheses. If you find a match, that basically means the one that you just read was a close, and the one that you just topped from the stack was the open, that basically means you have a balanced one. So whenever you have this case, so you just keep going with no problems. So let's keep going. Now we have a new open, a curly brace, and then we have another open square bracket, and then after that we have a closed bracket. Now once you have a closed bracket, again, we know that we have a closed bracket. Now we have to top and pop this one. So we're going to have it somewhere here stored in a variable. Now you compare this one with this one. If they match, that basically means we're good to go, and we keep going. So it's good to go. Of course, remember, we have to remove this. And then we're just going to keep going. Now, after that, we do have this curly brace one as well. So what do we do with that? We save it somewhere. keep it somewhere, and then after that we're going to have to pop and top this one, and we put it next to it, and this is going to be removed. And then after that we're going to have to check and see if they balance each other. So this is an open, this is a close, so that basically means we are good to go. And then after that we have the last one, which is a close square bracket. So we have the square bracket, and then after that you're going to have to come here and top and pop this one. So as a result, we're going to have to compare this one with this one, and since they match open and close, that basically means we completed the whole expression, and we found every single opening parentheses has a matching close parentheses. Also very important, after you're done processing the whole string, your stack needs to be empty. That's very, very important. It must be empty for that expression to be considered as balanced. So you will get a balanced parentheses if you completed the process from the beginning all the way to the end, and all the open parentheses, you find a match for them, and at the end the stack by itself, it was empty. That's a case that would be true. It will be false if you finish the process of the scanning and your stack wasn't empty. There was one left or two left. That's the case where it's not balanced. Or if you have an open parenthesis and then you look for a closed parenthesis and they don't match, that's another case where you can say this is a not balanced expression. So let me just show you an example for a non-balanced expression. Imagine we have this expression here. Open 3 plus let's say, for example, 6 minus 2 multiplied by 3 plus 5 something like that. And I'm going to change it later to see if we have. So I'm just going to go try to do it fast this time. So what do we have here? We have the opening parenthesis, and then we have a square bracket, and then we have another opening parentheses. And now after that, we have a close bracket, which basically match with the opening here. So that would be okay. And then after that, I have a closed square bracket, which basically match with whatever I have here. And I'm done. But again, I'm left with one opening parenthesis here. So that makes it non-balanced. Now, of course, if I have a closed parenthesis here, it will make it balanced. Now, let me just put it this way. So I have a curly brace here. Okay, let's do the same thing here again. And you got curly brace, square bracket, and then parentheses. And now after that, we have the closed parentheses. So this is going to be out. Then we have square bracket. This is going to be out. And then we have the parentheses. Now we have an open curly brace, and we have a parentheses. So they don't match. So the whole thing is not balanced. And that's basically how checking the balance of expression should go. Now, to create a program to do that, the idea is very simple. First of all, you need to scan your expression. You're going to treat the expression as a list of characters, the strings. And then the moment you see one of the open parentheses, that's where you take it and you push it into the stack. Now, the moment you see a closing parentheses, you're going to have to stop at that point, and then you're going to go to the stack itself, and then you're going to have to top and save the element inside a character, and then pop it and remove it, and then you check. If one of them is open and the other one is closed, then if they match, then you just keep going with the process. If they don't match, you're just going to have to break the loop and just return false, as this is not balanced. And once you're done, this is very important. Let's imagine you finish the process of checking all these parentheses. Before you make a decision, like you find every single parentheses matches. Before you make a decision that this is a balance, just go ahead and check the size of that stack. If the size was 0, you can immediately say it's balanced. Otherwise, it's going to be false. It's not balanced. So the rest of this PowerPoint presentation is just to show you how it's done and how do you check some analysis applied here. This is the algorithm. This is just a demonstration for the process. Now he just decided to go in the opposite way. I went from bottom to the top. He's going from the top to the bottom, which basically doesn't mean anything. And now here we go. We got a close parenthesis. And the top here is a close parenthesis, so that matches. You take it out, and then you have the close parentheses and match. And here's the piece of code if you are willing, if you want to have a look at it. Of course, I believe you should be able to write it by yourself. There's not that big of a deal when it comes to that. Now, in addition to those applications that I mentioned, we have a lot more applications. We're going to talk about them in a sec. But now we're going to move on into the implementation. Now, for the implementation part, we can, as I said, implement stack using a vector or using a list or using a DQ, which is something we're going to cover later. But either way, the idea is very simple. Whenever you're going to create a stack class, inside that stack class, there will be a member, and that member is just going to be a vector. That's it. So we got the stack that you created, which basically going to have an element, which is going to be a vector in this case, or it could be a list. It depends on which data structure you're using for the implementation. Now, of course, each one of those, the vector by itself comes with a list of methods. We can override them if we want, or we can just use them if we want. Now, this here is the implementation. What I did, basically, I had my own version, and my own version is very simple. And I'm going to go ahead and show you that. Here it is. So I created a class. I call it myStack. In this myStack, I decided to create two variables. One of them is called size, and the other one is called back. Size is going to store the values, and back is going to store the index of the last element in that vector. Now, you may agree with this or not agree with this. Why don't you just use the data types and data members of the vector itself? Well, we have methods in the vector to return those values, and I feel like calling a method may take a little bit longer time than just trying to have access to a variable that we have here. Anyway, this is something we can argue on, but the idea here is very simple. As you can see, this is the most important part, which is creating a vector. I decided to go with integer. I don't want to go with templates right now just because the code is going to be a little bit longer and more complicated. So I decided to go with just integers. Now, as you can see here, we have the default constructor. At the beginning of the default constructor, I decided to set the size to 0 because there's no elements. Back will be -1, not 0. And then I'm going to reserve 30 elements. Of course, this is a number you can decide, whatever you want to do with it. Now, we have push function, which we can I created here. And this push function, it's basically going to be very equivalent to the push back that we have in vectors. But the idea here is we're going to push back that element to the vector. I'm going to increase the back by 1, and then I'm going to increase the size by 1. Now, pop is supposed to remove an element from a vector. So here it is. Pop back, the last element, of course, decrease the back by 1 and decrease the size by 1. Top is just supposed to return the last element that we have in the vector. Of course, I decided to treat it as an array, but again, if you don't like that, you can just say top, return vector top. That's what it's going to do. And then this is me trying to print the elements in that stack, of course. What you should know, remember here, I'm not trying to remove them. This might not be very, very close to how stack works, but I just decided since a stack is just a vector, I will treat it like a vector. So I can go ahead and print the elements without actually the need to remove them. But again, remember, if you're going to go use STL, let me just show you that. This is my STL, not this one. Here it is. This is the STL that I showed you before. What if I want to do this? Cout my stack, and I'll just put the value of 2 here, and line, semicolon. You can see here he's complaining about this. Okay, he doesn't like using the subscriber operator. And that, again, is understandable because, after all, if we can actually have access to the elements using the indexes, then it's not a stack anymore. The whole idea is that you only have access to the last element. And that's, again, what we have. This is the issue that we have with STL. Now, remember here, there's a reason for why I'm not allowed to do that, because this is against what stacks are defined for. If I run it, it should give me an error. And here it is. So let me take that away. But again, in my stack here, this is my creation. And since I know a victor is a victor, so I decide to go with this. But again, this is again against what stack is all about. So this is not supposed to be here. But I just showed you that it's possible. You can do it. Here we go. Return the size and then check if it's empty. If size equals 0 or if back equals -1, you can use either one of them. It'll return true, otherwise return false. And now you can see here, I created a stack of a type of integer. Let me just go and change the name of the main function to be main here. And I'm going to come here and put this as main1. Now let me save the work. I'm going to come back here and run it. You can see that I'm pushing all these elements. This is going to print the elements starting from the first element all the way to the last element. Again, remember, this is against what stock is all about, but I'm just showing you that you can do it if you create your own version. This is going to pop it, remove the last element, and then it's going to show it again. Check the size to the top. Let me just run it now so you can see the implementation. And here we go. So this is the elements that I inserted in that order. Now I decide to remove the last element I pushed, which is 8, and you cannot see it here anymore. The size of it's 8 elements. So here we go. And the top element is 7 in this case. Now, when it comes to the implementation of list, the idea here is not going to be that complicated. Since it's a list, we don't have indexes, or we don't have the index of the last element. I don't need that. You may agree here if I actually needed it here or not. But here we don't have it. We don't even can have it. So I just created a size again. Again, there is a function called size in list. You can use it, but I decided to go with my own size. And now when you create a stack for the first time, you set the size to be 0. And as you push element, increase the size and push back an element of that list. And then we got pop. Again, check before you remove an element. This is something I was supposed to do here. I just remembered now. Before you start popping elements, just make sure that you have an element here. So check if the size equals 0. That basically means a queue is not a queue, it's a stack. Stack is empty. Otherwise, reduce the size by 1 and then pop back that element. Top, return the back of that list. Printing, I'm using iterators here to go through those elements one by one. Remember here again, this is against what stock is all about. But again, I'm just showing you that it's doable from a programming standard. But if you want to actually think about a stack, you're not supposed to be able to do this. Size, return the size, check if it's empty, and you will see that this will give me the exact same values. And here we go. Okay, so this is the implementation of the stacks. If you want to create your own version, of course, it could be a little bit more complicated if you just want to go ahead and create templates instead of type of integer. But I just decided to go with integers just to simplify the process. You do have some demonstrations here to show you how does it work in a linked list. Just to give you an idea about how does it work in a linked list, you start adding in elements to a list when you want to implement a stack in a linked list. And instead of adding an element next to the one that you have, you're just going to start, whenever you add a new element, that new element is going to be the head of the stack. What do I mean by that? So at the beginning, for example, here, we inserted, or we pushed back an element inside this list, and that element was A. Now, when you're going to push a new element, instead of having the next of A to point the new element, no, that new element by itself is going to be pointing to A, and this is going to be the new head. And the same thing here, I'm pushing a new element here, so this is going to be the new head. You see, this is going to be the end of my stack. And you keep going, and this will be, where is it? Oh, this is just the class in of itself. So this is going to be the top of the stack, which is basically the last element I inserted inside that stack, which is E. And again, every time you want to remove an element, basically this pointer here is just going to be pointing to the next element, and that's how it's done. And of course, this implementation here basically means you're not even using a list from STL. You're creating your own version of STL if you want to get into this level of details. Okay, so you can see here, yes, this is what he's doing. He's not using a list STL. He created his own version of that node, which again, it's doable. If you want to do it, go ahead. But again, if you just want to use STL, it will make it a little bit easier. Now the implementation between comparison implementation. Now the implementation shows let's see here. What does it mean that? But deleting operation, I'll get to that point later. But let me just discuss this. Which one of those two implementations should we consider? Should we go with a list or should we go with a stack? Oh, sorry. Yes, should we go with a list or should we go with a vector? Now, it depends on what are you using here. For example, if I'm going to use the STL library to create a stack, you can have access to the first element or you can have access to the last element using iterators, which basically makes the process a little bit easier. Since the whole thing is going to be done with the last element, then the iterator of that list at the end should give you access to the last element so you can change it and modify it the way you want it. Also, with vectors, you can do the same thing, but since there's no need to have access to any element in the middle with the stacks, and we're always going to be dealing with the last element, so most of those operations that we talked about is going to be a big notation of 1. That's basically what it is. Now, so from a standard of efficiency of which one of them is going to take longer time to be implemented, the big notation should be 1 with no problem. The question you may think about, okay, since the time complexity is exactly the same, maybe the space complexity should be something to consider. And in that case, I will say yes, you should go with vectors instead of linked list, because with linked list, you need to have a space to store the pointer and the data itself. So the space that's going to be consumed is a lot more comparing to a vector. But when it comes to performance, they both get the same job done. Now we're going to move on to additional applications. Now I do have a long list of applications. I'm going to go through them right now and we'll see how does it work. So the first one, let me just give you the list that I have in mind. So we already checked if palindromes strings. We checked for the parentheses balance of expressions. We can use a stacks to convert a decimal number to a binary. I want you to think about that. And we can use stacks to do what? To evaluate expressions. So that's another type of applications. And let me see if there's anything that I'm missing here. So there's the evaluation expressions, which I'm going to talk about in a sec. Yep, those are the applications we're going to talk about. And let's keep going. So what is the evaluation of expression? What does that mean? Well, before we get into that point, we need to understand that there are 3 different ways to write expressions. Arithmetic expressions. The first one is called the postfix, prefix, and infix. We human, we like to use infix. And infix is basically the list here, the column here in the middle. You put the operand, the operations, and then the operand. Operand, operation, operands, and so on. We use a parentheses sometimes if we want to decide which operation needs to be done before the other one. Now, infix, I'm going to put that on the side right now. But what we're going to be dealing with, we're going to be dealing with postfix and prefix. And then later, I'm going to tell you about the infix. So what is a postfix? Postfix basically means you put the operands first, and then you put the operation. Like here, 4 multiplied by 7 in infix is basically 4, 7 multiplication. This expression here is going to be 4, 7, 2 plus multiplication. Now, one of the benefits of the postfix over the infix is that we don't need a parentheses here. And it's very, very important for you to understand or to be able to convert each one of those to the other. So, for example, let me take this expression here. I'm going to write it down. So it's 3, 4, 7. Let me just create a new one. I'm going to come here and do 3, 4, 7. Let me go back. Multiplication to division and plus. So multiplication to division and plus. So this is here. This is my expression. As you can see, it's postfix expression. What do we do to convert this into, let's say, into an infix? We basically scan the, let me make sure that I got it right. Yes, multiplication for 7. Okay. We scan the expression left to right, and we go like this. So we got 3, and we got 4, and we got 7. And because I have multiplication, so multiplication is going to be here, and 7. And then we got 2, and we got division, so this is going to be dividing 2. And then we got the add, which is basically going to be between those two. So 3 is going to be multiplied by the whole thing here. Okay? I don't need to have a parentheses here, but I just can put them. And I know that the result of this multiplication is going to be divided by 2. And let me just go back and make sure that I got that right. And here it is. Of course, these parentheses are not necessary. I can understand what's going on without them. Anyway, the point here is we don't use, what we do here, we use stacks to evaluate an expression like the one you see here. And the idea here is very simple, and I'm going to show you how is that done. Just take this away. And then after that, I'm going to show you what is the postfix. And from the postfix, we'll be moving on to the infix. So, prefix, sorry. So what are we going to do? We're going to create a stack here. And in this stack, basically, we're going to push the operands. Remember this, the operands are going to be pushed. So I'm going to push 3, and then I'm going to push 4, and then I'm going to push 7. Now, the moment you read an operation, this is where you stop. You come here and you take those two numbers, 7 and 4. Remember here, 7 is going to be to the right and 4 is going to be to the left. The order here is very important to understand. So you're going to have two variables. The first one is going to store 7 and the second one is going to store 4. Now what are you going to do? You're going to use the operation and multiply them together. And remember here, 4 is going to be multiplied by 7, not 7 multiplied by 4. This is a big deal because sometimes division, subtraction will mean a lot different things. Now, after you're done with this process, you're going to have to, of course, I forgot to mention here, is that you must remove those two elements here when you start using them. So they're going to top them and pop them. So we're going to have to take that out, and we're going to have to take that out as well. Well, you know what? Let me just erase it with this. Okay, and now I'm going to go and put drawback. So the result of this multiplication, which is 28, is going to be pushed in this area. Now after that, what do we have? We have 2. So we push 2 because it's a number. And then after that, we have the division. Just like we did with the 4 and 7, 2 is going to be stored, topped and popped, and then 28 is going to be topped and popped. And then we're going to divide them by 2. Okay? Which basically means the result is going to be 14. Now remember here, I have to remove those two elements from that stack, of course. So the result is 14. I'm going to take 14 and then I'm going to push it here. Once I'm done with that part, what do I have after that? We have plus. And because I have a plus, then basically that means I have to put 3 here, put 14 here, and add them together, and then I will take this out. Okay, let me just keep doing that. And the result of adding 3 to 14 is basically 17. And now you take 17 and you push it here. By the time you get to the end of the expression, you need to have a stack that has and hold only one value. That will be the result of this expression. And that's how it works. So let me make sure that it's 17. Did he give me the value here? Yep, it is 17. And that's how it works. So let me just here summarize the rules again. You can have an empty stack, and then you're going to start pushing the numbers to the stack. The moment you see an operation, you top and pop the two elements you have of that stack, and you perform the operation. Very important, the order of those values you're popping and topping from the stack. You get the result, you push the result back in the stack. Once you're done with that part, You keep going, you keep going, you keep going until you get to the end of the expression. Your stack, by the end you get to the end of the expression, should hold only one value, and that value is going to be the evaluation of that stack, that expression. Now, postfix, in the other hand, is different. The postfix basically means you have the operands, which basically in numbers, so let's say 5, 6, 7, multiplication, 2, 3, plus, let's see here, what else I can do, and then I can put division, and I can put a multiplication again. Oh, wait a minute, this is postfix again, my bad. Let me just go back, start fresh. So postfix a prefix now. Prefix basically means you start with the operations and then you put the operands. So for example, multiplication plus 2, 3, and then subtraction 11, 14, for example. And I'll keep it this simple here. That's how I'm going to keep it. So this is my expression here. 14, 11, multiplication, adding 2, 3, minus 11, and 14. How do I evaluate this expression in this case? Well, the idea here is very simple too. The postfix. With the postfix, we scan the expression from left to right. But if you do the opposite now and you scan it from right to left, you're basically going to be doing the same thing. So what we're going to do, we're going to start with the right value here, which is 14. You push 14 here, and then you push 11 here, okay? And then what do we have? You have the negative, the subtraction operation. So you put the subtraction here. Now, this is very important. Previously, what we said you're going to take, well, actually, yeah, it's exactly the same. You take this is going to be 11 minus 14. Okay? This is, again, let's look at the difference between previously. We said the first element that you're going to take is going to be to the right of the operand, and the second element is going to be to the left of the operand. Now, this is going to be the opposite. You see the top is going to be to the left, and the one underneath is going to be to the right. So this is going to be 11 minus 14. And in this case, this is going to be basically negative, how much, 3? Okay, so I need to pop those elements and remove them and replace this with negative 3. Now after that we have 3, which is going to be coming here, and then after that we have 2, and then what do we have? We have the additional operation, so we're going to have plus here. Now remember here, the first operand, the top operand here is going to be to the left, and this one is going to be to the right. Remember here, this is extremely important to understand. It's the opposite of the postfix. This will give you a value of 5. Of course, remember here, those are going to be erased. This is going to be erased. So I'm going to get 5 pushed back here. Now after that, I do have the multiplication operation. So remember, 5 is going to come here, negative 3 is going to come here, and I will get negative 15 as a result. Remember, this is going to be removed. This is going to be removed. Okay, so negative 15 is going to be post here. That's how we do a postfix. Now that we know how to evaluate the prefix expressions, I'm not going to go through the infix. It's a little bit long and complicated, but I'm just going to give you some headlines about how do you do that. The idea here is for a prefix, if you have a prefix that contains parentheses all the way, all the possible, like with every 2 operations that need to be done, it will be surrounded with parentheses, then the process is going to be quite easy. You're just going to have to push elements, push those parentheses inside a stack. You will need 2 stacks for that case. One of them to push the operands, and then the other one to push the operations. And then as you go, you read and you push also the parentheses inside the operand. So the moment you push a close parentheses, you're just going to have to start pushing, popping and topping all the elements and go back to the stack of operations and using them. But that's the case if you use all parentheses. But if you don't use parentheses, it gets a little bit more complicated, because you're still going to need to use two stacks for that, but you need to actually decide which operation has a higher priority than the other one when you have multiple operations inside that stack. Anyway, this is out of the scope of this lecture today, because if we're going to go through that, a whole chapter, a whole week would not be enough to cover infix. So let me just go to the PowerPoint, and this is just to show you some examples of how to evaluate Postfix. This is the algorithm that I explained. This is the project, the code in C++, and how does it work. It's, again, something very simple. You should be able to get it done by yourself. So this will be the end of this video, and just to quick reminder about what we talked about today. We talked about stack, and we talked about the implementation using STL, and we talked about if we want to implement it yourself using vectors or using lists, and we talked about the applications of stacks and the application that we covered, which is finding if a string could be read left to right or right to left, the same thing, palindromes, and we talked about application of evaluating expression and see if it's balanced or not, checking the balance of expressions with parentheses, and then we talked about the evaluation of expressions, postfix, infix, and then I mentioned, but I didn't show you how do you convert a decimal number to binary. So thank you for watching.